Today, we're going to go back and visit square roots. So the first thing that we know from this year is we want to memorize our perfect squares. So let's talk about what a perfect square is again, just to refresh our memory. So perfect squares are things like the square root of 16, the square root of 25, or the square root of 144. So we know the square root of 16 is 4 times 4. What number multiplied by itself will give us 16? The square root of 25 is 5. What number multiplied by itself will give us 25? So 5 times 5. And the square root of 144 is 12, because 12 times 12 equals 144. If you see a square, what you're seeing, and I'm going to put this on in green, would be that 4 times 4 will give us 16. So the area of that square is 4 times 4. We've got our 16. So our 5 times 5 gives us our 25. Our 12 times 12 gives us 144. And we're looking at our perfect squares. Likewise, if we're trying to find something, we can say, let's just take 16, for example. What squared would give us 16? Something squared would give us 16. And you know from using your calculator, the button here that you'll see when you're using your calculator has the x squared button, and on top of it in a different color, it has the square root button. And up in the left-hand corner, we know that if we use that second key, we can toggle between doing the square root or the square. So square roots and squares cancel each other out. So if I take the square root of both sides, what I end up with is this cancels out, leaving me with my x. And then the square root of 16 is 4. It's simply 4 to the second power would give me 16. Okay, so that's all fine and good. When it's perfect squares, we can memorize. Recall I asked you to memorize the perfect squares from 1 to 20, which would be the square roots of 1 to 400. All right, let's move on to when it is not a perfect square. We will use our perfect squares to help us. This is fun. So if we have the square root of 45, we first start and say, okay, well, we've got our things memorized. I'm going to go ahead and show, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Okay, so that's great for me. So I know that my number, the square root of 45, is somewhere between 36 and 49, which means it's somewhere between 6 and 7. It's not 6 because 6 squared is 36. It's not 7 because 7 squared is 49. I know it's between the two. But if I actually want to simplify this, I do a different process. So I look to 45 and I say, what are the factors of 45? So I can list them all, but what's more important is that I can do one of them as a perfect square. In fact, the largest perfect square. So I'm going to immediately say that I know that 45 can be made by the square root of 9 times the square root of 5. 9 times 5 is 45. That is the largest perfect square that goes into 45. Why is that helpful? Well, it's helpful because I know the square root of 9 is 3. So I can replace the square root of 9 with 3. And I know that 5 is not a perfect square because if I look down in my list, I jump straight from 4 to 9. So I must leave this as the square root of 5. Remember, if a number is in front of a variable or a square root sign, in this case, that times sign is implied. So 3 square roots of 5 is equivalent to 3 times the square root of 5. We just don't include that. This would be our answer. So we can simplify a square root, or more appropriately, write it in a different form by using perfect squares. Let's try another. Here we have the square root of 80. Okay, I'm going to go through that same process, and I want you to get comfortable doing that as well. Only this time, I'm going to say to myself, well, I'm going to start at 5. 5 squared would be 25. 6 squared is 36, and I could even start higher. 7 squared is 49. 8 squared is 64. 9 squared is 81. Okay, so if someone asked me to approximate where on the number line this square root is, I know it's somewhere between 64 and 81, which means it's somewhere between 8 and 9 on a number line. That's helpful for me to know that the length of this square here and here is somewhere between 8 and 9. It's in between those two. you might even go further and say, well, it's a little closer to 81, so it's probably like 8 point something. If you used the calculator to take the square root of 80, in fact, which I'll do now on my calculator, you would find that the square root of 80 is 8.94. Okay, so I'm going to leave that as approximately 8.9. We could round. But what I'm asking you to do is use the square roots to approximate and keep it not as a decimal, but as a number times a square root. So you have to think about what are your factors of 80, and this gets a little more tricky. So I'm going to list them all, 1 and 80, 2 and 40, and then you can say to yourself, well, maybe I just keep dividing 80 by 3. Oh, you might find, oh, that's not even. This is where your divisibility rules from 5th and 6th grade come in. So the more you have them, the better you get this with factoring. So now you have 4 times 20, and then you have 5 times 16. Okay, what I want you to notice here is that there are, in fact, 2 factor pairs that have a perfect square in them. We want to take the largest one. So the largest one is 16. We can get there with a smaller one, but we can get there faster with a larger one. So I'm going to rewrite this as the square root of 16 times the square root of 5. And I know the square root of 16 is a perfect square, which is 4. I actually didn't include it in my perfect square list, so I'll put it here at the bottom. And that would be 4 roots of 5. Remember, we don't need the times sign, so we can rewrite this as 4 square roots of 5, making that middle step unnecessary. So 4 square roots of 5 is about 8.9 when you do that multiplication. Let's look at the next one, and this will be our last example. So the square root of 28. So this time I'll make my perfect square list. I'll go ahead and start at 1 again. And I don't have to go as high this time. I only have to go up to 6 squared. And I know that the length of this square is somewhere between 5 and 6 because the square root of 28 is between 25 and 36. So if I were to do this in a calculator, I know that I have x squared equals the square root of 28. If I took the square root of both sides, whoops, I'm sorry, I messed that up. So let's do that again. X squared equals 28. Something squared equals 28. I would take the square roots of both sides to find out what x is. What is the length of this side? X times x gives me 28, and I'd end up with my decimal equivalent if I did that on the calculator. So I would say, let's go ahead and find the square root of 28. And on the calculator, that's 5.29. So I know it's between 5 and 6. It's a little closer to 5. But what I want to do is use my perfect squares over here. So I know my factors of 28 are 1 and 28, 2 and 14, and 4 and 7. Well, for me, the only one that's going to work here, the only one that has a perfect square in it is 4 and 7. So the square root of 28 can be rewritten as the square root of 4 times the square root of 7. We know the square root of 4 is 2, so the answer is 2 times square roots of 7, or 2 roots of 7. If you do in your calculator the calculation 2 times the square root of 7, that of course will be equivalent to 5.29. There are different ways of writing the same thing. You'll find in algebra when you get into factoring and specifically they'll say reduce a square root or simplify a square root, you'll need to know that 2 square roots of 7 over the 5.29. The estimation is a valuable skill so that you know if you are able to kind of visualize what would that square root land in? How big should it be? What if I miskey on my calculator? What if I end up with, 36? Well, I know I did something wrong if I come up with a square root of 28 is equal to the number 36. I made an error. So that is the end of this lesson.